In this video, I'm going to be looking at this 4-drive NAS system from Asustor. We'll go from unboxing to installing the drives and getting it set up. And then we're going to do some link aggregation to get the fastest possible network speeds, and we'll set up an SSD cache. I'll give you my thoughts on this unit as we go, and I'll explain some of the choices that we made. So if you're in the market for some fast network storage, maybe this video will be helpful to you. We've been using this particular NAS unit for a few months now, so I'll let you know how it's performed for us, though we'll save detailed performance testing for a future video. Let us know in the comments if there's something you'd particularly like us to test. So this is the Asustor Lockerstor 4 AS6604T, which is a bit of a mouthful, and that's why Erin has named it Ralph.
Ralph's a great name.
Erin names everything in the studio, including the pot plant.
Leave Stefan alone.
So a couple of questions then. Will Ralph work for us, and is it nice and easy to set up, or will you need to be a Jedi master of incomprehensible IT? There's only one way to find out. We particularly needed a fast network attached storage or NAS system for our small video studio. And for us it really needs to do two things. Firstly, it needs to have plenty of storage for all our files, and secondly, it has to be fast enough so that we can work from it. So we've got the choice of editing video directly from the network storage. And this Asustor is a good solution because it has two 2.5 gigabit Ethernet ports, and those can be aggregated if you have a compatible switch to give you 5 gigabits per second total bandwidth. I'll talk more about that in a bit. Now, of course, we may be using this NAS for video files, but you could use it for any file storage. And like many of these NAS devices, it's not just a storage box. Really, you should think of it as a mini server. There are downloadable apps and services, which mean you could use it for more than just file storage. Want to host a website or some virtual machines? Maybe a database, media server? Well, you can do all of that. So first of all, let's see what you get in the box. And full disclosure here, Asustor sent this unit for review without charge, and we're not required to return it. Likewise, Seagate kindly supplied the hard disks on the same basis. Neither company gets to see or change the video before we post it, so this is our honest and unbiased opinion, which is actually based on a few months of using it in a real-world environment. In the box we get the unit itself, which has 4 removable drive sleds or trays, and you can see that each of these trays has mounting holes for 2.5-inch SSDs, so you could make this a super quiet and fast solid-state NAS, but we'll be mounting conventional spinning disks in ours. The unit has an external power supply which is included with an appropriate plug for your region. There's a couple of Cat5e network cables and all the screws that you'll need for mounting your drives. Now let's do a quick overview of the unit itself. We've got an LCD display on the front which is off most of the time. It does give you useful information when the NAS is booting up, and there are 4 buttons here to the side that allow you to navigate the menus, but you'll probably want to use the web control panel to configure it. At the bottom here we've got a USB port with a one-press transfer button. The idea being that you can plug in an external USB drive, press the button, and it either copies everything off the drive to the NAS or backs up the NAS to the drive. We've got some helpful indicator LEDs and a power button. And what I like about this is when you press the button to switch the unit off, it actually performs a graceful shutdown. At the moment, Ralph here lives in the studio, and since he's loaded with spinning drives, we do have to switch him off when we record video. On the rear of the unit, we've got the power input and the 2.5 gigabit network ports. Now these can be aggregated together, and I'm going to talk about that a bit more in a moment. We've got 2 USB ports here. All of the USB ports on this device are USB 3.2 Gen 1, so that's 5 gigabits per second. Now, as I said earlier, this is basically a mini server. There's a Celeron processor inside powering it and 4 gigabytes of RAM, which you can upgrade to 8 gigs. And you can use the HDMI output on the back to access the Asustor portal. I can't tell you any more than that because I've never tried it, but I'll put a link to the specs in the description. There's far too much to cover in this video, at least not if I want you guys to stay awake. What we need to do is get some drives installed into the NAS. Obviously the unit isn't supplied with drives, you need to provide your own. So in our case, Seagate kindly sent us 4 of their 8TB Ironwolf drives. These are a perfect choice for a unit like this, and it's what Asustor recommend. I'll put the price of these and the NAS unit itself up on the screen so you can get an idea of where we are cost-wise now. Naturally, you could get larger drives, or you could start with just 2 drives and then add more later. And speaking of adding more later, Asustor do have a 4-drive expansion unit available, and you can connect up to 3 of these for an additional 12 drives. The downside is that they connect via USB, so you'll need to assess if that's a suitable upgrade path for your workflow, but it might be a useful solution for backups. Let's install the drives to the trays. There's no quick install features here. Each drive has to be physically screwed to the sled, and that took a little while. I found that the supplied screws have quite a shallow slot in the top, so it took a few goes to find a screwdriver that would work. I think this could be improved with some better quality screws. The drives do slide easily into the NAS once they're mounted, and then we're good to go. They are apparently hot swappable, but I haven't tested that. Now, we do also have 2 NVMe drive bays inside the unit, which you can use to create an SSD cache, or use for additional storage. They're not particularly easily accessible though. You have to open the NAS by removing the case screws and sliding off the cover. When I did that, I found one M.2 slot immediately on this blue circuit board, but where's the second? Well, it turns out you have to remove the board because it's on the reverse side. So functional, but not particularly user-friendly. And it would be nice if these could be accessed via a side door. As you can see, there's enough space in there to maybe provide 4 slots, and that would really enhance the functionality of this unit. We'll come back to the SSD cache later. First, let's fire the NAS up and see what happens. If you visit the Asustor website and select your model, it provides full instructions to get set up, and you can also download the Asustor Control Center app for Windows or Mac OS. Think of the app really just as a discovery tool to find the IP address that's been assigned to your NAS and then to take you to the web control panel. When you do that, there's the usual certificate error which you can safely bypass. This error doesn't mean that there's a problem with security, it's just that the secure certificate hasn't been signed by a trusted authority. It's a self-signed certificate, and that's absolutely fine in this case. We get a nice login screen and we get a guided tour of all of the features once we've signed in. Here's the home screen with the various apps, and I'm going to go straight for the Settings app. Here you can configure options like your network settings, notifications, a basic firewall functionality, and you can configure a trusted certificate if you want to. In the Services app, we can configure the various protocols for file sharing. Samba or SMB is enabled by default, which is supported by Windows, Linux and macOS. But if you're in a Mac environment, you can enable AFP and even enable network time machine support. Now, incidentally, I haven't noticed any performance difference between SMB and AFP when accessing this NAS from a Mac. We also have NFS, FTP and even WebDAV. You can actually run a web server with virtual hosts straight from this settings panel, and you could in theory use this to host multiple websites on multiple domains. It's probably not the best choice for that, but it's a nice to have. And you'll notice some other protocols appearing in the list, including SFTP and the possibility of running an rsync server. And this would be incredibly useful for backup routines and file syncing between multiple locations. And I just love that this stuff is already installed and you just need to switch it on and set it how you like it. There's an activity monitor app which gives you useful information on CPU, memory, network and drive usage. And you can even see a list of running processes. Unsurprisingly, the NAS is running a Linux OS, and this control panel is providing easy access to its features. Presumably you can access via a terminal to do a custom configuration, though that perhaps defeats the object of something like this. The Storage Manager gives us an overview of the drives and the storage volumes which have been created, but we'll get back to the storage volumes in a moment. I just want to show you App Central, which is like an app store where you can download additional features for your NAS. There are more advanced web server applications and PHP. If you're serious about hosting websites, though, you can also set that up through the Web Center app, and that will download the server applications for you and help you to configure and manage them. We've got database server apps. There are apps to help you easily use your NAS as a media server, and Seagate have made an Ironwolf health management app, so we'll download that. Once I downloaded it, it wasn't immediately obvious how to access this particular app, because in this case it's an add-on to the Storage Manager, which enables you to get a little bit more data on the health of your Ironwolf drives. Now obviously with any network file storage system, you'll want some form of access control. And you can set that up with the Access Control app. There's quite a few options available, including features for Windows Active Directory. But you can just create users directly on the NAS, give them access to folders and apps, and set up storage quotas. And I think there's enough functionality here to satisfy most security requirements in the target market for this device, which is power users and small businesses and teams. There's a backup and restore app which provides a bunch of options for remote sync and backups. So you can create internal and external backups. You can also control the functionality of that one-touch backup button. You can choose whether it copies from the USB device that you plug in or copies back to it. And I like these simple, user-friendly options. And I like the fact that if you want to do something more custom, well, you can do that with rsync or SFTP or download an app. It's really flexible. And Asustor makes this even easier with their Easy Sync Manager for syncing files between your computer and the NAS, and then the Snapshot Center for backups. I haven't played with a lot of these apps because I don't need to, but again, there's so much here to accommodate users of all types with a wide variety of needs. The External Devices app lets you control anything that you plug in via USB. Here I plugged in a Samsung T5, which was recognized and immediately accessible to the system's File Explorer. So this could be used for backups or file copies. It could be made available as a shared device. You could also share a USB printer via the NAS. You can set up Wi-Fi or Bluetooth if you've got the correct dongle plugged in, and even access a USB UPS or optical drive. So that's a pretty complete overview of the web control panel and all of the features that are available. Let's now talk about storage volumes. With any setup like this, you need to think about which RAID mode you'll be using. And naturally, the Asustor supports lots of different RAID modes, along with single disk modes and JBOD. Looking at the RAID options though, we've got RAID 0 or striping. Now that allows you to build a volume that spans across multiple disks. That can give you huge performance benefits and means that with our 4 8TB drives, we could create one enormous 32TB volume. But that would give us no redundancy. And actually, you increase your risk of data loss the more disks that you include in a stripe, because hard drives fail. And if one disk fails, the whole volume is ruined. Incidentally, SSDs are more reliable than spinning disks, and you could put 2.5-inch SATA SSDs into this NAS. But generally, I'd say RAID 0 doesn't make sense for this type of device. You might instead choose RAID 1 mirroring. This gives complete redundancy by mirroring your data across 2 or more disks. And there are performance benefits when reading the data because those drives can be accessed in parallel. The downside though is that you only have the capacity of one drive. So in our case that would be 8TB or 16TB if we created 2 mirrored pairs. And if we did that, we could use RAID 10, which is a combination of striping and mirroring. Using 4 disks, you could set up your 2 pairs of mirrored disks and then put them together as a striped volume. This gives you improved performance for both reading and writing, and it provides redundancy. But the capacity will be the total of 2 disks, so you're effectively giving up half your storage space. In our case, we'd get just 16TB, but you do gain a whole load of redundancy. But you might also choose RAID 5 or 6, which uses striping and distributed parity. This can seem a bit like magic, and it's probably beyond the scope of this video to go into detail, but if you'd like me to do an explainer on RAID parity, let me know in the comments. Whilst you're there, how about a thumbs up and a click of that subscribe button? You know it makes sense. Now I decided to go with RAID 5 and make a single large volume for this setup. So that means we get total space of 24TB and we have 8TB reserved for parity. And this means that any one of these 4 disks can fail and we should be able to recover the volume. We're going to get great performance from the striping and we get a bit of redundancy. And best of all, we retain 3/4 of the capacity of all of those drives. So a decent trade-off. Except that there are good arguments for not doing this. Firstly, a rebuild of a RAID 5 array can be painfully slow. And secondly, any RAID scheme which uses parity is at risk from something called unrecoverable read errors, or URE. Again, I'm not going to dive into the detail here, but there is an important takeaway. RAID is not a backup. You still need separate backups for your data. For me, RAID is about performance improvements, and in this case, the possibility of an easy recovery by swapping a faulty disk out. And the level of risk will depend on the amount of data being stored. As it happens, one of the new Seagate drives did fail, and the RAID array continued to function in a degraded state. The disk itself was toast, so I reached out to Seagate to see if they wanted to replace it, which they didn't. That is fair enough though, because they already sent us 4 disks for promotional consideration. So I decided to buy another disk myself. I installed it and the RAID array was rebuilt successfully. But I'll say it again though, RAID is not a substitute for proper data backups. Okay, this is turning into a long video, but hopefully you've gotten a good overview of what's possible with this Asustor AS6604T. And there are 2 optional features that I want to demonstrate. First, let's build an SSD cache. I bought 2 Samsung 980 SSDs, both are 1 TB in size. Now we need to open the NAS up and remove that mounting board to install the drives. And I should say that we used the NAS without the cache for a few weeks and performance was good. But I was keen to see whether the cache would make a difference over the long term. Now once the NVMe drives are installed, we can go into the admin panel to enable them. Inside the Storage Manager app, we can see that both drives are installed and they're recognized, but by default they are inactive. If we go to Volume Management, we can create an SSD cache using this wizard. With a single SSD, we can accelerate read performance, but since we have 2, we can accelerate both read and write. Now you can see that there is a message of caution here. The SSDs will become part of the overall volume. So once we enable the cache, we won't be able to remove those SSDs without first switching it off via the admin panel. And I'm guessing that that will take some time. Now it is a fairly simple process, especially as we only have 1 storage volume. So we just select both drives and then choose the capacity that we're allocating. If you had more than 1 volume, I'm guessing you could divide the cache between them. In our case, we'll just use all of the capacity. Now there's also an option here to skip sequential I/O, which we want to do, but it might be worth explaining why we want to do that. On a traditional spinning hard disk, the physical locations of files can be anywhere on the disks. They're not always neatly located together, so that means the drive heads have got to do some work locating each block. And there may be a tiny delay waiting for the disk to spin around to align with the head. Now of course the heads move very fast and the disks are spinning very fast, but all of these tiny delays add up and slow down file operations. And basically, that's what we call random I/O. But if you're accessing a single large file, the blocks are probably, but not always, physically next to each other. And that's called sequential I/O. SSDs don't work that way. They've got flash memory, so it doesn't really matter where the blocks are physically located within the chip. It's so fast, it makes no difference. And this is why SSD caches can be beneficial. They can provide copies of frequently accessed files, reducing random I/O on the spinning disks, and improving the random I/O performance of the volume, especially if you have multiple users accessing files. But an SSD cache won't make much difference if the data write or read process is sequential. And if it's making no difference, then you're just wearing out the SSDs unnecessarily. So it's better to skip sequential I/O to improve performance and extend the lifespan of your SSDs. Hopefully that makes sense. Now in our use case, we're typically accessing large video files, so I don't know how much we're going to benefit from the cache, but it seemed worth it to me based on the relatively low cost to do it, and time will tell how effective it is. I'll put the prices up on the screen so you can see our running total. Once you've completed the wizard, the Asustor mounts the SSDs and restarts the system, and it then starts to synchronize the cache, which takes a while. I seem to recall it was about an hour in our case. So again, it's a pretty simple thing to do. You don't need a computer science degree or mad engineering skills. I think the SSD installation could be a bit more user-friendly, and I believe this is something that Asustor is improving with its 2nd generation NAS units. Finally, let's now look at the other main way we can speed up our data access, and that is with a switch which supports link aggregation. As we said earlier, we have 2 2.5 gigabit per second Ethernet ports, which can be aggregated for a total bandwidth of 5 gigabits per second. But why use 2.5 gigabit ports? 5 gigabit and 10 gigabit network ports exist. Why not use those? Are these ports going to be fast enough? Actually, yes, for a small NAS like this. Remember, 8 bits to a byte, so 2.5 gigabits per second is the same as 312 megabytes per second. And this is realistically more than enough for a spinning SATA disk, especially when in a RAID configuration. Being able to double that bandwidth with aggregation to 625 megabytes per second makes this a very usable NAS, especially with our specific application of video editing with 1 or 2 concurrent users. It also means cheaper network switches and network adapters. 10 gigabit networking is really expensive, and it might even require new cabling, whereas 2.5 gigabit networking works fine on your existing cabling. Now, for our purposes, I bought a couple of USB 2.5 gigabit LAN adapters. Both are USB 3, one has a Type-C connector and the other is Type-A. They both work on Windows or Mac without needing any special drivers, you just plug it in. Perfect. I put links to these models in the description. Finding a network switch that offers all of the features needed wasn't quite so simple, but it's not impossible. I settled on the Netgear ProSafe MS510TX, and again there's a link in the description. This switch supports link aggregation, which is obviously key to getting the most from this NAS. And again, I'll pop the price up on screen and the total cost now for our setup. Obviously you can have more or less drives, smaller or larger drives, and the SSD cache is optional, but I would personally budget for the switch because link aggregation I think is a key benefit of this particular NAS. This Netgear switch has 4 1 gigabit Ethernet ports, so these are great for network uplink and internet access. Next to that we've got 2 2.5 gigabit ports, and I use these to connect up to the NAS using the included Cat5e cables. Next we've got 2 5 gigabit ports and then 2 10 gigabit ports. One is RJ45 and one is the SFP type. And we use all of these ports to connect to our computers. Now this is a managed switch, so it's got a control panel you can access. Not particularly user-friendly for newbies, but setting up link aggregation is pretty straightforward. We head to the switching page and then click on LAG for link aggregation. Then we can set up LAG membership by just selecting the ports that we want to link together. And that's it for the switch. Nice and easy. Now we go back to the Asustor's control panel. We go into Settings, Network Interface, and click Configure. If we click on Link Aggregation, we can then combine the 2 ports using various different modes. I went with Round Robin, which gives you both load balancing and fault tolerance. And it's not really within the scope of this video to discuss the different options. But Asustor do provide this information on their website, which will be linked to in the description. Once we apply the configuration, the NAS begins to operate under a single IP address rather than 2 separate IPs, and we get access to the full 5 gigabit per second bandwidth. The difference in performance is noticeable. In our studio environment, this means that we can edit video directly from the NAS. Our largest files are from the 6K Blackmagic RAW footage that we shoot here in the studio, and there's enough bandwidth for an editor to work with 2 streams or 2 camera angles over the 2.5 gigabit network connection. So that's perfect for us, and that's the Asustor Lockerstor AS6604T, or as we call it, Ralph. It's not the cheapest storage solution, but I'm not convinced there's a cheaper way to get this amount of functionality and usefulness. Now there are things that Asustor could improve, and I suspect that they will in future generations, but overall it is quite difficult to find fault with this device. In all the time that we've been using it, it's been reliable. Even when we had that disk failure, it was easy to rebuild the array. I love the user interface and the simplicity, and the fact that there's so many more advanced features for those who want them. We've had a few different NAS units over the years, and we still actively use a couple of QNAP units similar to this one. But the Asustor, in my opinion, is superior. I hope this video was useful to you, and I will try and answer any questions that you might have in the comments section. I've put links to the various products that we've featured today, and the channel does make a small commission if you buy anything from the links, so thank you in advance for your support, and all your subs, your shares, your likes, and even your dislikes. We'll see you again soon for some more geekery.